We have for the next part, we are going to kind of journey through a little bit of history. With the history that you need to know, the big takeaways is you need to know who who actually discovered the different parts of the atom and how they discovered it. And then you want to know kind of a general picture of what the atom looks like over time. So I drew these little things just to kind of help out, I hope, with the atom and kind of what they thought that it looked like. Had you been here, we would have drawn this on the board with like a little timeline. So I just made these little cards in order to go through those. So we started with the word atomos, and with the word atomos, we just looked at, in general, who came up with that term. The tiny indivisible particles was Democritus. So again, I just had that one up there. Democritus would draw an atom as just a circle. So he thought that they were just tiny indivisible little spheres that didn't have guts inside of them. Then the next person that we had was Dalton. Dalton used a lot of Democritus's theories, and Dalton would have done the same thing as Democritus. It's just a tiny indivisible particle, and he also said that all the particles were all identical if you have the same element. They were indivisible still. We didn't know about anything inside of the atom until we get to this guy, and this guy's name is J.J. Thomson. J.J. Thomson was actually not looking for anything inside of the atom. He was doing a lab where he was looking at a cathode ray tube. And with the cathode ray tube, what you actually have is electricity going through it. So it's a vacuum chamber. There's a video in this section that you'll want to watch about the cathode ray. I don't have one to show you, but I have a different demo that I'm going to show you with the lab next week with the flame test. But he was using this cathode ray tube, and he was electrocuting the vacuum chamber. And as he was electrocuting the vacuum chamber, he had a phosphorescent strip in there, and that phosphorescent strip kept creating this line that goes across it. And the line that goes across it, you can kind of see it right here. That line really baffled him. He had no clue why that line of light was actually being emitted when you electrocuted it. It didn't make any sense. He knew that there were atoms inside of there, but beyond that, it was a mystery. So then he decided to do some more tests. One of the tests that he did was he put a magnet to the glass chamber. And when he put the magnet to the glass chamber, he realized if he put the negative end to the glass chamber, the line of light actually repelled away. So it actually took the line and bent it down. But then if he took the positive end of the magnet and put it up to the glass up here, then the line of light was attracted to the magnet. Well, we know that magnets opposites attract. So with those opposites attracting, he figured out that there has to be something that was negatively charged inside of the atom. So he was dealing with, this is the video that you're going to want to watch on this next slide. This teacher is teaching his class, but he has a cathode ray tube that you can see there. And he actually explains pretty much what I just said, but he actually shows you, and you can see that little line of light. So what he figured out was there were negatively charged particles inside of the atom. And with those negatively charged particles inside of the atom, it's not a very good circle, but it's a circle, he figured that they were just spread throughout the atom. There was no rhyme or reason as to why they were placed where they were, but he said that it's kind of like we would say chocolate chip cookie. He called it a plum pudding, that these negatively charged particles, which he called electrons, like it says on this slide, are negatively charged, and they're just scattered throughout. So this little brown ugly thing here is a cake. It's a plum pudding. We don't eat it here in the United States very often, but it's a molasses-based cake with plums. So we would kind of probably associate more with like a chocolate chip or an M&M cookie, that we have the cake part and then we have the M&M part, or the cookie part and the chocolate chip cookies, that they're just scattered throughout. And what he hypothesized was the negatively charged particles, the electrons, are scattered. And then like the cookie part or the cake part that's there would be positively charged, and that's what actually holds it together. So his model of the atom just had a sphere, And then scattered throughout the sphere, he had those negatively charged particles, which he called electrons. Now, everybody was kind of okay with that until the next person came along. And the next person that came along discovered the proton. This guy's name is not JJ. His name is Ernest Rutherford. And Ernest Rutherford, he was a person who was doing a different test. That test that he was doing was called a gold foil test. So he took alpha particles, which is a type of radiation. You really don't need to know what those are. But he was shooting it at a piece of gold foil. Gold foil is actually a just really squished flat piece of gold. Aluminum foil is aluminum that's crushed real flat. Silver foil, tin foil is just a metal that's squished real flat. Gold was used here because you can actually take gold and you can squish it so flat that it's almost down to just a single layer of atoms. If you have a cube of gold that's 1 inch by 1 inch by 1 inch on each side, you can actually make it so flat that you can cover an entire tennis court with that little cube of gold. So he was taking really thin pieces of gold and he was putting it inside of this little arena. It's called a screen. But he was putting it inside of there and he was shooting it with alpha particles. What he thought would happen was these high energy would either pass all the way through, or it would be like a piece of tissue paper getting hit with a machine gun. It would just like get blown to pieces with that much energy. So he took the alpha particles, he shot it at the piece of gold foil. Most of the energy passed all the way through with no problem. That was great. The issue was some of the little particles that are there, the alpha particles, ricocheted away. That doesn't make much sense. Why would the majority of them go through, but then some of them hit something and bounce back? So with this gold foil test, he had to figure out what was going on there. So as he was trying to figure out what was going on there, this video is a slide that has, or this slide has a video of what I just said. So you're going to want to watch this one too. But what he figured out was inside of the atom, there's a nucleus. And the nucleus is super, super, super compact in the middle. This is showing two different parts in the nucleus. We only know about one of them right now. But he hypothesized that you have the electrons on the outside and they're still scattered. So this picture isn't the greatest, but it's the best that I could do. The electrons are still scattered, but on the inside now we have the nucleus in the middle. And that nucleus in the middle must contain positively charged particles. Now, with those positively charged particles, they are the part that is neutralizing, I guess, the negatively charged electrons. So we have electrons on the outside of the atom, and then we have the positively charged protons in the middle. So Rutherford not only discovered the second little component of the atom, which is the proton, he also discovered the nucleus. So we have the nucleus in the center. The nucleus is super, 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 super teeny tiny in comparison to the rest of the atom. It's extremely compact and it's extremely dense. This is Faroe Field where Mizzou plays football. We still have season tickets, like right there. But with the football stadium, if they allowed me to walk onto the football field and hold up a quarter, the size of the quarter would represent the size of the nucleus. The entire rest of the stadium, way out here to the nosebleed seats, all of those would all be like where the electrons are able to move around. So when we're talking in size reference, the nucleus of the atom takes up a minute amount of space. The majority of the atom is actually where the electrons are able to move around. So when you see pictures like this, they are not to scale. The nucleus, if I had a picture like this, you wouldn't even be able to see it. So this one, again, not drawn to scale. So we have a nucleus in the center. The nucleus in the center has the positively charged protons, and then now we have the negatively charged electrons around the outside. So the charge of a proton is positive. Electrons are negative. However many positive protons you have, you're going to have the same amount of negative electrons in order to cancel each other out to make a neutral atom. That's going to be very important next week. When we look at the size difference between the two, the proton is 1,836 times larger than an electron. So if you look at these pictures, the protons are huge in comparison to that little bitty speck right there, which would be the size of an electron. So electrons are super, super, super teeny tiny. The protons are much larger, and you're going to find out here in a second when we talk about Chadwick that neutrons are the same size as a proton. So now the third part of an atom. You already know that there's protons, neutrons, and electrons. J.J. Thomson discovered the electron plum pudding model spread throughout the atom. Rutherford discovered the nucleus, which contains the protons. The electrons are still scattered outside of the atom, just like a chocolate chip cookie. So now these neutrons, they were discovered by James Chadwick. James Chadwick was actually doing some math when he discovered this. That math is always going to get in the way in this class, right? But we have the positive and negative forces, but he realized that half of the mass was missing. We knew the mass of an atom. And so when you look at how many protons are there, the biggest chunk of the atom, because remember electrons are super, super, super teeny tiny, about half of the mass was missing when they did the calculations. So then they started to really dive inside of that, and they started to think about it. And when they started to think about it, they went, wait a minute, all these things are positively charged, but they're stuck together. If you think about two magnets repelling away, they shouldn't stick together. They shouldn't be as compact as what they are. So what they hypothesized was we have a neutral part of the atom to cancel out the negative and the positive charges. And the neutral part of the atom is about the same size as a proton. So what happens there, it actually helps to absorb away some of that positive charge to make it super, super, super compact. So it's going to be the same size as a proton. So protons and neutrons are the same size. Electrons, super teeny tiny. And what they're going to do is they're going to create nuclear forces. Neutrons are neutral. They create nuclear forces. And with your nuclear forces, all that they're doing is it's just helping to hold together the nucleus of the atom. So that way, all those little positive protons will stick together. So when you look at the atom itself now, we have this electron cloud, is what we're going to call it here after a couple people. So we have the electron cloud where the electrons are allowed to free roam here. And then in the center here, we have protons and we have neutrons. So in the nucleus of the atom, I have my protons and my neutrons, which were discovered by James Chadwick. My electrons are still scattered around the outside of the atom. So today we added on to our timeline. So we have Democritus, tiny indivisible particles. Dalton, tiny indivisible particles. Then J.J. Thomson discovered the electron. He discovered that using the cathode ray tube test. Electrons are negatively charged and just scattered throughout. It's called the plum pudding model. Then we had Rutherford. Ernest Rutherford discovered the nucleus of the atom by doing the gold foil test. The nucleus of the atom contains the positively charged protons, and then the electrons are just scattered throughout. And then finally we had James Chadwick. We don't need to know what test he did because he didn't do one. He discovered that inside of the nucleus, not only do we have protons, but we also have neutrons. The neutrons create nuclear forces. Those nuclear forces help to hold together that nucleus of the atom. So we're going to jump to the next section in a different video to find the number of protons, neutrons, and electrons.